Okay, hello everybody, and welcome to another episode of Move with a Doc. So as always, feel free to kind of move, stretch, walk, spend some time outside in nature while we talk today about body intelligence. So what do I mean by body intelligence? I took a little bit of liberty with this topic, but we're going to discuss today how our bodies are quite intelligent and very complex when it comes to eating. Specifically, I want to discuss the extremely complicated pathways of hunger and weight regulation. And we're going to touch on why it can be so difficult to lose and maintain our weight, and things that you can do to maybe maintain your weight and control your hunger. Okay. So as a board certified bariatrician, which is an obesity medicine expert and a health and wellness coach, I really do understand all too well the very complex mechanisms that are involved in maintaining and losing weight. Or as we sort of like to refer to it in the weight management world or the bariatric world is how do we maintain energy balance? It's kind of a buzzword that we talk about, but basically we're talking about how do we manage our weight and maintain kind of our weight. So we're going to touch on why it can be so difficult to lose and maintain weight, like I mentioned. And then you're going to hear me use that term a lot of energy balance, because again, calories, after all, that's what calories are. They're energy. Okay, so that's kind of what this whole talk is going to be referring to. So to start, I'm going to give you a little bit of a short kind of physiology overview. This isn't to bore you, but this is really to drive home a point because this is the biggest question I get in the office from my patients. Okay, so I want you guys just to be educated. I want to drive home a point that energy balance and weight is a very complex neurohormonal mechanism. And not all of it is within our control. Okay, so there's a lot of contributing factors, including environment, lifestyle, genetics, even epigenetics. This is the stuff that happens in utero to us. And there's a lot of other things that go into maintaining our weight and then contribute to either being overweight, underweight, and just maintaining our weight. So it's a very challenging issue to tackle. So as humans, our bodies have systems that have evolved to regulate adipose tissue, which is our fat, okay, the fat in our body, basically. The kind of older thinking was that our adipose or our fat tissue was this inert tissue that we just carried around, and it just stored energy in the form of fat. It insulated our bodies, and that's all it was good for, okay? So the new thinking, and many of you may know this, but the new thinking is that our adipose tissue is actually an endocrine organ. So I'm going to say that again. It's an endocrine organ. It's an active, dynamic endocrine organ with several different cell types. And there's a complex interplay of neurohormonal factors that determines the synthesis of it, the breakdown, and the storage, okay, of adipose. So when I first started taking my bariatric course and started learning about all this, and my mind was literally blown because it's just a conceptual way to think about adipose tissue that I'd never thought of it that way before. And once you start thinking of it like that, you really get a better understanding of what all goes into energy balance and weight maintenance. Okay, so again, our adipose tissue is an active endocrine organ, and the adipocyte or the fat cell is really a little endocrine factory. You can think of it as, okay? There's over 600 adipokines that have been known, okay, or kind of have been researched and studied. And some of them I'll just mention. So we have adiponectin, we have leptin, estrogen is even made by some of these, TNF alpha, which is an inflammatory protein, fatty acids, and so many more, okay? So let's briefly, again, I said mini kind of physiology lecture here, but just briefly so you have an idea of these terms that you may have seen in the media lately, terms thrown around, commercials on TV, all these different things. So I think it's important just to be educated. So let's briefly discuss leptin. So leptin you may have heard about. This is kind of known as the obesity hormone, okay? It's been studied quite a bit. We know that it increases in the body with increasing adiposity. So the more fat and adipose tissue you have, the higher your leptin levels. So it is high in obesity. Adiponectin, the other one that I mentioned, is actually low in obesity, and it decreases with increasing obesity. Leptin is supposed to tell our brain how much energy, again, or fat is on board. So if our system was functioning optimally, our brain would recognize this and it would get rid of that excess fat. But in obesity, it's felt that the system is actually dysregulated due to leptin resistance. So you'll hear that term sort of thrown around, like leptin resistance. And that's more for normal people. There are actually genetic forms of leptin resistance, so I'm not talking about that. Those are genetic conditions that are known and treated very differently than kind of a run-of-the-mill obesity. Another hormone you may have heard of, and is not from the adipocyte actually, but another hormone you may have heard of, and we've talked about it before, is ghrelin. Ghrelin is it's kind of an acronym, so it stands for growth hormone release inducing peptide. Okay, so if you think of the GHRE, that's the first part of ghrelin, sounds like grow. Ghrelin makes us grow and increase in size. That's just kind of a way to think about it. It's a peptide that's secreted by our stomachs, actually. And then that signals to our brain, the ghrelin does, that we are hungry and it's time to eat. So ghrelin peaks before meals, as you would expect. And that's when ghrelin starts peaking, we start foraging for food, okay? In studies, it's shown, an interesting thing that's been shown is that ghrelin in our bodies was suppressed the longest by protein meal, compared to if we had a meal with just carbohydrates and fats. But carbohydrates did suppress ghrelin the fastest. So kind of if we looked at a time-dependent manner, eating a carbohydrate-rich meal did suppress ghrelin the fastest, but there was rebound, and then ghrelin rebounded. So again, protein suppresses ghrelin the longest. So when you diet, ghrelin is kind of the hormone that remains elevated, and it's what's making you hungry, because in essence, the ghrelin is trying to get you back to your set point as it's recognizing you to be in this underfed, low caloric state, and that's why you feel hungrier when you're dieting. So just to give a little insight on that mechanism. So now let's talk, we kind of mentioned, leptin, adiponectin, ghrelin, some things that you might hear. Let's talk about the energy regulation system. So this is where it gets really interesting and intricate, but there are a lot of factors that go into maintaining our weight or our energy balance. So first of all, we have things like our environment and our lifestyle. These are the things like the taste and the smell of food, reward pathways in our brain, the availability of food in our environment, the types of foods that are available in our environment, in society. Our circadian clocks play a role. Our cues, our social habits, our behavior patterns, all of this plays a role in kind of this clump that I'll call environment and lifestyle. But on the other hand, we have our brain, okay? But even that's not so simple. It's not just as simple as our brain is involved in energy balance, because we have, on the one hand, a cognitive and emotional brain. And then the other side, we have what we call our metabolic brain, okay? And both of these crosstalk with each other as well. So we have this kind of back and forth chatter between all of these factors as the energy comes in, the energy goes out. And then, in addition, we have nutrient sensing, okay, all these nutrients that we eat that come in through our organs. And then we get feedback to our brains from those organs. We have the gut, liver, muscle, pancreas, okay, all super important, sending all these signals back to our brain, okay? So why do I tell you all this? Because it's super complex, right? It's not just so easy. It's definitely not calories in, calories out anymore. That's a really old adage. And And again, just keeping in mind that there's this really complex kind of interplay. So let's really talk about where the home kind of, because there is kind of this central thermostat, the home of this homeostatic regulation does occur in our brain, okay? And specifically, kind of in that metabolic brain, it's in the hypothalamus, so deep within our brain. We have our hypothalamus, and that's where all of this magic is sort of happening. Within the hypothalamus, and I'm not going to get into too much detail, but as you would imagine, there's different areas to the hypothalamus. We have the lateral hypothalamus, that's the hunger center. This is where the hunger neurons hang out, okay? And the other kind of around that area, we have the ventromedial hypothalamus. This is the satiety center. What that means is this tells us when we're full, when we're sated. This is where all the leptin receptors are. If everything was working normally, remember, leptin tells us how much energy is on board, we can stop eating. So we have hunger centers, satiety centers. We also have a periventricular hypothalamus, and we also have an arcuate nucleus. So we have all these different things, all within the hypothalamus in our brain. All of these areas are communicating with each other, sending signals back and forth. And don't forget, we already talked about it, but again, it's taking input and feedback from our organs, right? Our gut, muscle, pancreas, okay, and our adipose tissue, okay? So we talked about it, but our adipose tissue is that factory of adipokines. It makes the leptin, which communicates with the hypothalamus. Our pancreas makes the insulin, which you've all heard of insulin. This communicates with those neurons also in the hypothalamus. And then our stomach, which is probably one of the main organs that's super important too in this feedback, that secretes ghrelin, and that communicates with the neurons too. Okay, so I said a lot of things. Why? Because to recognize that if you want to think about it, it's a really kind of a yin-yang that's happening, this really intricate balance that's happening in the hypothalamus of what energy should we ingest and absorb, and then what energy do we need to use and expend, and then what energy do we need to store in our adipose. So all of this is happening up here. So ultimately, all of this is going to determine whether or not we end up storing that energy as fat and we gain weight, or we expend that energy and then we lose weight. So I think really the topic of today is, body intelligence. And I think this just really speaks to just how much of an amazing thermostat our bodies really are. So we talked about the brain a little bit and kind of where the thermostat is, so to speak, in the hypothalamus, but let's talk a little bit, because it's not all happening just there. We also have what we kind of refer to as the hedonic system, okay? This happens in a different part of the brain. This is our prefrontal cortex in the front of our brain. This is where our dopaminergic neurons are, where the dopamine is, okay? This is a system that we hear about a lot in drug addiction. It's what makes food and sex and other activities feel good to us. That's kind of the feel good center. So this is involved when we see, that like amazing piece of pie or cake, and we get that dopamine boost just by looking at it, and it motivates us to eat it, okay? So the hedonic system prefrontal cortex really modulates our food intake, but it's really based on how food tastes. It has nothing to do what our body needs in terms of energy, okay? So when we're fasting or dieting, our hedonic drive is really strong. And I think we've all noticed that when we're really trying to cut down on those calories, and all of a sudden things just seem that much more amazing to us, and it's hard to really resist. And then lastly, we have our cognitive brain. Okay, so we talked about the hedonic part of our brain, and we have the cognitive brain. This is our decision making, okay, our executive function. So it's a little bit different than just the dopamine areas. And this is some of where our emotional eating can stem from, okay? This involves really our thoughts and our emotions about eating, some of the reasons why we eat, our responses to food, some of our impulse control, And there's been some studies that really looked at in overweight and obese patients that there is an increase kind of in the right prefrontal cortex in patients with obesity as well. So there is a lot to do with the brain and kind of all these like, the drive to eat, okay? And then lastly, what I want to talk about today was, we talked a lot about the brain, but our environment plays a large role also kind of in this entire energy regulatory system. So we could break this down. We have I always kind of like to call it like we have our micro environment and our macro environment, okay? Small, big things. So small, I always love to talk about kind of the gut microbiome, but that's part of our microenvironment. Our stress is part of that. Our sleep patterns, our circadian rhythms, that's all part of our microenvironment. On a bigger kind of scale, the macro environment are things like our temperature, infections, air pollution, endocrine disruptors, which I won't get into, but different chemicals that are secreted from different objects, plastics in our environment that do affect us, okay? Now, we don't have a lot of control, right, over our macro environment. We live in this world, and there's going to be things out there that we can't control. We do have a little bit more control over our micro environment. We have control over the things like our diet, our activity levels, medications, sleep, stress to some extent, circadian disruption. So these are parts of our microenvironment that we can try and change. So there was an interesting study that was done in mice. I find this one fascinating. There's mice that they raise what they call germ-free. They're raised in a bubble, essentially. They have no gut bacteria, and they're normal weight. They do a gut microbiota transfer from an obese mouse to the normal mouse. And then that mouse adopts the phenotype of the obese mouse and becomes obese itself. So of course, this led to like this huge amount of research into the gut microbiome. And what they found is, through a lot of this research, that there are differences in the bacteria in patients who are obese. They have a low Bacteroides count and they have a higher Firmicutes count. So just different bacteria, and that there is implications for weight. They have found that this ratio can be altered by our diet and potentially also by the use of pre and probiotics. Don't know the specifics of all of this, but lots of research has gone into the gut biome, and that's why it's just so fascinating, an area that I'm really interested in. Another area that I wanted to just kind of touch on for a moment is stress. We always, they talk about stress and how it's implicated in weight. Now, I'm not talking about acute stress because there's differences in acute stress, which is our fight or flight kind of response, but we're talking about chronic stress. So chronic stress stimulates our adrenal cortex and our adrenal glands. That's that little gland that sits right above our kidneys, okay? In response, then, our adrenal glands secrete more cortisol, which can lead to insulin resistance, and it increases our cravings for sugar and fatty foods. So some of this has also been really studied. And what they found is that chronic stress does stimulate the physiology that's involved in obesity. So just another area to kind of think about in your microenvironment. And then I know we're getting kind of short on time, but lastly, I just want to mention sleep deprivation. And we've talked about this a little bit in the past, but just to tie it all together, chronic sleep deprivation leads to chronic fatigue. And this alters kind of on a cellular level our thermoregulation. So basically what chronic fatigue, chronic sleep deprivation does is that it increases our appetite, decreases our energy expenditure, so we're not burning as much, decreases our leptin, and it increases, as you guessed, your ghrelin levels, that hunger hormone. So you're going to feel hungrier. So it also increases our insulin and our cortisol secretion. So we get increased storage of fat. We get altered sugar metabolism and glucose metabolism, and it inhibits muscle building as well. So take-home message there, that sleeping better is crucial to our energy balance. To our energy balance mechanisms, basically, and helps that mechanism sort of stay intact. Okay. So I think it's about 12:20, but I think I will end here, but I just hope that this kind of gives you a little bit of appreciation for how truly amazing our bodies are, how intelligent, complex, and intricate the energy kind of balance mechanism is. I hope you learned a little bit about obesity, the hormones involved. But really, I hope that if you suffer and struggle from managing your weight, are overweight or obese, I hope you realize that just how intricate this process is, and that it's not all within our control. It's not so simple as calories in, calories out, and that there shouldn't be guilt or shame around not being able to maintain a normal body weight or a normal BMI. So I think when we understand things like this better, it gives us a new perspective on how to just how to kind of look at that. But if you have any questions, feel free to reach out or email me as always. So thank you.